Hello, everybody. How's it going? Hope you're doing well. Hope you're doing well. My name is Michael. Welcome back to the stream. A little bit of a later stream today. I want to first just apologize. Sorry for coming on a little bit later than normal. I usually stream, every day around 7 p.m. PST, but currently it's 8:53, approaching 9 p.m. I just had a long, long day at work, actually. Eyes are a little droopy. I'm tired here. But I'm feeling good for wanting to learn some coding and stuff. But I just had a little bit of an accident at work. Not even my accident. I was just a bystander. I was just in the area, and someone's filter exploded, and uh, I got completely soiled in chemicals and product, and so yeah, I had to go and wash off and go through that whole process and that report and go. I had to go to like an urgent care and get just checked out per precautions, and it was nothing bad, nothing corrosive or flammable or nothing. So it was just a biological thing that just had a pigment and a little bit of a smell. So it kind of ruined some of my clothes and. Anyways, it's all right as long as my I'm okay is what matters. But yeah, quite the eventful day. But then I could have just left work after that, right? But I had to finish something just in regards to my own project. So yeah, hey Addie, what's going on? How's it going? Welcome in. How you doing? It's awesome to hear from you. Yeah, I'm all good. I just it was just a an organic, material and nothing. It was there was nothing in there that was too. It was potent or whatever. It was just it was potent material, but it wasn't like corrosive or anything. So, but the funny thing is it wasn't even like me. I was just happened to be in the area at the right time, and just my luck uh, it went off. But my coworker actually, he had to go into the safety shower. He was entirely soiled from head to toe. It was for me. It just hit the right side of my body, mainly my lab coat, and then soiled into my hairnet, and then obviously into my hair and in my side, my cheek, and my face and stuff here. I had goggles on and everything, but my coworker he had to go actually use the safety shower, and yeah, that's the first time I've ever seen that had to be used. So it's really interesting, quite the day. But yeah, we have like a safety team that like came in, and it's a pretty big organization. It's a Fortune 500 biotech company. Um, I mean, you can definitely look it up like on my LinkedIn and stuff if you really really want to know. But I won't say it aloud here, but you can find it if you want to know. But um, yeah, they have like all that in place, and they sent us the people that got impacted and contaminated. They sent us over to the urgent care that they work with, the doctor's office that they have a partner with to get checked out, and I have a follow up on Friday. So it's all like comped through them and stuff. So it's like all their programs. So I mean, yeah, it's definitely would be a little liability thing if they. What's going on? Playing my music out here or my podcast. All right. But yeah, sorry I'm a little late. That's why I just got I was in the wrong place at the wrong time. Someone's filter exploded. Luckily, it wasn't. No one got hurt from any filter pieces. It was just a small filter, and it wasn't like a stainless steel apparatus like we usually set up. It was just a small filter, but it still gained so much pressure, back pressure that it literally looked like a crime scene. Like for about for the radius, I'd say of about 30 feet, 45 feet. Like the material itself is called bilirubin, and it's just a material that is just really it has like a stain, and it's has a smell to it. It's just an organic material. I believe it's an organic material. But yeah, and or biological material rather, probably, and biohazard material, and it was in solution, right? And so then it just went everywhere, and it was like it has like a red yellow hue to it, so it yeah, Dexter Morgan. It literally looks like a crime scene. Um, but yeah, I was just in the area. My tank was I was working on my big 1,000 liter tank, which is a big stainless steel tank. I have a ladder. I step upwards and climb to add things into it, and it seals with big clamps on either side that you wrench down, and then you pressure it up with argon gas to displace oxygen and preserve. And then it has like a chiller system like on the wall with like all these piping. It's a huge, huge lab, like manufacturing chemistry lab. It's not. It's like it's very. It has those elements of like your high school lab with the benches and stuff, but then it has these huge, vats for making product inside of them, and then so it has like these chillers. And so I was over there messing with the argon line because I was going to pump up my tank and get it pressurized so I could um, I was going to take an oxygen reading on it because a part of my procedures every day um, I just have to read the oxygen levels. So I was getting ready to do that, and then the people next to me on their tank, because there was just tangent, there was another 1,000 liter tank. They were the ones that did it, and just boom, just blew, and just all on the right side of my face. I was just I stood there, and it was just like, what just happened? And then I looked over, and the guy that was working on it directly, he was just entirely yellow and red, just like he was just dripped like just completely. And so he we had I was like, just go to I was like, so I quickly like I called my supervisor. I was like, code red, code red. And like so then like they ran in, and like the safety team ran in. It literally was like out of Monsters Inc. Like you said, like the what is it? 2319, 2319. Like, but yeah, so I had a pair of scrubs. Yeah, I had a pair of scrubs here I was wearing because my clothes got all destroyed, and yeah. Ah. Yeah, right, Ryan. The contamination team in Monsters Inc. Hey, Coding Mountain Man, welcome. Yeah, I'm all right. It was just a. I guess like looking back, I didn't think too much of it in the moment. I was just like, oh, whatever. Like, let's just wash it off, and I'll do whatever they want me to do. It's probably just the end of my day, right? It's whatever. But thinking back, like what if that was like an acidic material or something? Like it could have like burned, like really done some damage, right? Like think about people that get like like hate crimes or like those terrorist attacks where they like uh, you know spray people in the face with acid or whatever, and it just completely disfigures them. So um, yeah, like definitely could have been a lot worse. Now that I really think I've been thinking about it. The first person in the company ever to use the shower. Heisenberg, is that you? Do you guys like Breaking Bad? How many of you guys have seen Breaking Bad in here? I have this problem with shows where I'll start them and I'll get about 3/4 of the way through, and then will stop. Like I can't not finish shows for some reason, because I think because when I finish them, I just know it's over, and like I don't know. I think it's a psychological thing. Like I've started The Office probably and gotten to the last season probably 7 or 8 times, and I never really finished it. Okay, we gotta jump in here real quick. I want to read about 5 or so pages, of the DSA in Python. This is going to be just a chill, probably just a chill, quick stream to hang out with you guys really fast. I know, sorry about my, timing here. I just had that emergency at work, so, but I still wanted to come in here and hang out with you guys for at least a little bit. All right, so we are on breadth first tree traversal. Okay, so we'll do 3. This is breadth first tree traversal. Okay, although the pre-order and post-order traversals, okay, let's quickly go back and remind ourselves. Remember the pre-order traversal, you start at some root, and then you go down, you specifically kind of take you split with, you take the leftmost uh, uh, child of that root position, and you go down from there. You ascend all the way down, and then ascend back to its these other places, these other nodes here. So if you go A to B to D, then you finish with going to E, but then you would go to C and then to F to traverse the tree from there. But with post order traversal, you you would do the same thing here for the beginning, but instead of skipping over to the opposite branch, you would from the uh, depth of 1 here rather than depth of 0. With a depth of 1, you would do post order and go to the leaf and then back up to C here. Okay. I don't understand trees at all. Have you ever like seen like a family tree or worked with like um, evolutionary tree diagrams or something like that? I'm really thirsty. Okay, sorry guys. All right. Although the pre-order and post-order traversals are common ways of visiting the positions of a tree, another common approach is to traverse a tree so that we visit all the positions at a depth of D before we visit the position at depth D plus 1. Interesting. Okay. Such algorithm is known as a breadth first traversal. Okay. Um, um, to traverse a tree so that all positions at depth D are visited before visiting positions at depth D plus 1. Right. So I'm assuming that this would go from A to B to C to D to E to F like that. So we'll see how that's my first assumption. Now, the order, I'm not sure. Right, you go A to B to C, but then if you're already on C, would you go to F from there and then back through here? Would that be more efficient? We'll find out. A breadth-first traversal is a common approach used in software for playing games. A game tree represents the possible choices of moves that might be made by a player or a computer during a game, with the root of the tree being the initial configuration for the game. For example, figure 8.17 displays a partial game tree for tic-tac-toe, where you initially have some empty screen. If you have X goes here, in the middle, you have O can go there or there. Why only those two positions? If X goes here, a partial game tree, or a partial game tree, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay, yeah. Okay, so it's just this example of these were just the positions that were made, okay. A breadth-first traversal of such game tree is often performed because a computer may be unable to explore a complete game tree in a limited amount of time. So, the computer will consider all moves, then responses to those moves going as deep as computation allows. Pseudocode for a breadth-first traversal is given in code fragment 8.14. The process is not recursive since we are not traversing entire subtrees at once. We use a queue to produce a first in, first out semantics for the order in which we visit nodes. Okay, that's interesting to note as well. So, running time, we'll do this there. We'll go here, do like this. We'll do example, like so. But I want to make another bullet point here is that says um, uh, the process is not recursive like the post order and pre order traversal, um, since we are not traversing entire subtrees at once. We use a queue ADT can be used to produce a first in, first out semantics for the order in which we visit nodes. Okay. Wing Hong, hey, how's it going? It's awesome to hear from you. How you doing? How's your studying been going? Any luck with the jobs lately? I'm rooting for you. Hey, General Talks, how you doing? Welcome back. How's it going? Wing Hong says, I thought pre-order traversal was already like a breadth first. Well, no, because in a pre-order traversal, we would go from root A, we would split the childs in half and traverse the entire depth of the highest height, I guess, um, of the of the leg, right? So it would go A to B to D, but then we would go to E at that point, rather than right in a breadth first tree traversal, we would go A to B to C to D to E to F. In this case, we go A to B to D to E to C to F. So we go back up depth -1 from this position, right? 0, 2, 0, 1, 2. So we go depth -1 to get access back to this one, or maybe we just traverse all the way back and then go here in with 1, 2, 3 constant operations. Hey Yon, welcome. How's it going? Welcome back. It's awesome to hear from you. Where am I from? Yeah, I'm from the West Coast of United States, and I've kind of always remained over on this side. I'm gonna give myself a challenge and relearn data structure with a Spanish textbook. Yeah, that'll be rough for if you don't know Spanish for real. Me, I would be done for. There's no way. I'm struggling with English over here. Got it for you, Tim. You're awesome. Another rejection email. Yeah, you get that. Unfortunately, we have decided to move forward with other candidates at this time, and you are no longer in for consideration. We will keep your resume on hand in case you are a good fit for other role. Blah blah. Bull crap. Right. Okay. So the running time of this, the overall running time is O of n due to the n calls to the NQ and n to the DQ. Okay, so the running time is big O of n uh, due to the n calls to NQ and n calls to DQ. Nah, PTSD, Ryan says. Sorry, my bad. Did not mean to trigger people in the chat. I'm sorry. I'll be more considerate next time. I should have thought about that first. Hearing those words might send people into a panic. That's funny. My job application record is 2 for 145 all time. Let me cook. Yeah, that's a pretty good record for. Honestly, that's not bad. You're shooting like what? That more than 1%. So, for some people, I think you've got some people almost doubled or tripled on their on their acceptance rate. Uh, that's funny. Um, when I get a rejection, I just ignore it. Most of them are automated, but yeah, it's tough. Yeah, those I swear, why do they all have the same exact like template? It's honestly like um they just shared their homework with each other. Like it's it's honestly like companies are, they just shared it with each other. You are building a one app. Yeah, well, we're building a small business manager application in our currently in Python. So, but we work on this. We'll work on this a little bit later if we have time later today. We worked on it a lot the last 2 days though. Okay, so the example here. Let's take this here. Control C, Control V. So order of traversal here would be A to B to C to D to E to F using BFTT, BFT, using post order. Right, okay. Okay, so here is an example algorithm in pseudocode. So you have some algorithm, breadth first of some tree. Initialize Q to contain T dot root. So while Q is not empty, do the following. P equals Q dot DQ. So you'll DQ the first position, or DQ the first item. Position is DQ'd, right? Perform the visit action for position P. Hmm. Why do you DQ here? P is the oldest entry in the queue. Perform for each child in the tree with the children function at position P, the one that was DQ'd. Do, oh, so this is just our root, because technically in a queue, our root position would be the first or the oldest position using a first in, first out semantic. So that makes sense. So in a queue, right, you would line up, you would have let me get my whiteboard out. So you would have your queue here, right? And you would have your root, then you would have child one of root, right? Uh, child of root one, or child one of root. You have child two of root. Then you would have, you know, so you would p dot, or p equals q dot dq, right? Would remove r off the root into p. So p is equal to our root. And then we say for every child, for every c in Now, this just points. Okay, got you. I want to join a programming community. I feel alone learning myself. Well, that's the whole point of this right here. I appreciate you for being here. Consider joining the Discord too. Okay, cool. All right, in order traversal of a binary tree. Oh, so this is another one. Okay, here we go. In order traversal. For in order traversal. The standard pre-order, post-order, and breadth-first traversals that were introduced for general trees can be directly applied to binary trees. In this section, we introduce another common traversal algorithm specifically for a binary tree. Okay, so a specific to a binary tree. In this section, okay. During an in-order traversal, we visit a position between the recursive traversals of its left and right subtrees. The in-order traversal of a binary tree T can be informally viewed as visiting the nodes of T from left to right. Indeed, for every position P. The in-order traversals visits P after all the positions in the left subtree of P. Okay, so the in-order traversal visits P after all the positions in the left subtree of P and before all the positions in the right subtree of P. Pseudocode for the in-order traversal algorithm is given in code fragment 815, and an example of an in-order traversal is portrayed in figure 818. So if position P has a left child, then you recursively call in order on that left child. If position P then has a right child, you also recursively call on the right child. Algorithm in order for performing an in-order traversal on a subtree rooted at position P in a binary tree. So here's an example here. The in-order traversal algorithm has several important applications. When using a binary tree to represent an arithmetic expression as in figure 8.18, the order traversal visits positions in a consistent order with the standard representation of the expression as in 3 3 what? Oh. Okay, so you recursively break down the left subtree from root position P. Here, you break this one down, break this one down, break this one down. You do this operation here at the leaf. 3 plus 1 gives us 4. 4 times 3 right divided by 9 minus 5 plus 2, which gets loaded to here. Okay, got you. And that answer gets loaded. Then you do the same thing for here and then perform the operation. Okay. So we'll say, please give me a simple def for a in order tree traversal. An in order tree traversal visits nodes in this order: left subtree, root, right subtree. It's commonly used to retrieve the elements of a binary tree in a sorted order. Here's a simple definition. Okay, so and visits nodes in the order left subtree, root, right subtree. Um, it's commonly used to retrieve. Okay, here's a simple definition: traverse the left subtree, visit the root node, right? Traverse left tree, traverse left tree. Okay, got you. If you need a specific example, let me break it down. No worries. No worries. So what do we say about? Hold on. If we take this, how would it work? Does anyone of these have just one node? No, they all have two nodes. It work for this example, or would it not, because C has only one child? An in-order traversal works for any binary tree even if some nodes have only one child or none at all. It follows the same process, left, root, right. So it would start from A, traverse to B, then visit D, visit B, traverse the right subtree of B, visit E, visit the root back to A, then visit C, then F. So B, order traversal is D to B to E to A to C to F. Gotcha. Okay, so we'll take this, bring this here. Like so. Example order traversal would be D to B to E to A to C to F using in order traversal. Wait, will that do multiplication first before division? Yeah, I think it says albeit without parentheses, right? So I think you can infer that depth, right? Depth is kind of like parentheses. That's at least what I'm inferring. Now, if I'm wrong, please let me know. But this is kind of bound within its local scope here, at this, root node. The multiplication that's happening here does not apply to these two leaves. It applies to this child node, which is a parent of these two leaves. So, and whatever that answer is with this. So the addition is being applied to these two numbers in a kind of a localized scope here. So I'm assuming that kind of bounds parentheses and that such in that manner. Now, I don't know if that's a correct way of thinking about it, but that's just how I'm thinking about it. Wing Hong, you got a link for that in the Discord? You could shoot me or something? Let me know. Okay. is the running time big O of n? Yes. Every tree is visited exactly once. Read node. So, does it not take work or time to, you know, um, to travel to already travel back up to already traversed positions? Now we aren't, you know, performing operations at that step at that point just yet, but um, is this just a constant operation and not viewed in the time complexity? Great observation. You're thinking critically about the cost of the traversal, which is awesome. Wow, ChatGPT is really gassing me right now. Jeez, ChatGPT glazing over me right now. Oh my gosh. You're thinking critically about the cost of traversal, which is awesome. When performing in-order traversal using recursion, the process of traveling back up is handled by the call stack. Let's break it down. Traveling back up and the call stack. When we finish traversing down the left subtree, the program automatically returns to the parent root to process it. The returning happens due to how recursion works. The function call that process the left subtree completes, and the program continues with the remaining operations, processing the root or the right subtree. The cost of returning to a previous stack frame is constant, popping a frame off the stack. Why doesn't this increase time? Okay, yeah, because when the recursive call is due add overhead to the stack, each node is visited once during the traversal. That includes all the go down and go back up steps. Every node, there's one push onto the stack going down the tree, and one pop from the stack coming back up. This results in 2 operations per node, which is proportional to the number of nodes. Viewing the time complexity only counts to the number of nodes we visit and the work we do at each node. Since we are doing O of 1 work at each node, including the recursive calls, the total time is O of n. The space complexity for recursion is different. It's O of h, where h is the height of the tree, because the deepest recursive stack has the maximum number of h frames for a binary tree. This in summary, the traveling back up does take work, but it's constant. That's what I thought. Mm-hmm. Hey Manu, how's it going? Welcome in. Awesome to hear from you. Hey Guitar 6029. I like your name. I play guitar too. What kind of guitar do you play? I appreciate you for coming in and leaving a message. How long have you been learning Python? Yeah, so really quickly, for those that are new here, my name is Michael. Thank you so much for joining me. I actually turn 26 years old tomorrow. So for some of you guys, if it's the 23rd for you, it's my birthday. So yeah, so that's kind of fun. Really lucked out that I didn't get sprayed with chemicals, on my birthday, but rather today. But for those that don't know what I'm talking about, I work as a chemist. I have a degree in human biology and a minor in chemistry. I work as a chemist or a formulation chemist for a biotech company since I graduated college back in 2021. I'm currently a mid-level scientist too. Formulation chemist is my position title. I make biological controls, and yeah. So thank you guys. Thank you Wingong. Thank you Coding Mountain Man. You guys are awesome. I appreciate you. Yeah. So for me though, I have 2.5 more hours till my birthday actually officially begins. But yeah, 26 years old, right? That's crazy, man. I really don't feel 26. I don't think I look 26. I feel like I'm 22, maybe like because 21, 20 lower than 21, you're like lower than drinking age, so that's kind of weird. But so I guess 22 is probably the sweet spot. I think that's what I kind of feel, but I'm not sure. Uh, So yeah, I've been learning Python though for about I'd say at this point almost about 7 months. I started back in June of 2024, the beginning of June. I started with Harvard CS50P, where I completed that over the course of the summer of 2024. I did it very part time, a couple times a week, very, very relaxed, just trying to dip my feet in the water and see if this is something I wanted to invest more time into. And once I finished the course and the lectures, which I admit were very hard at the beginning, at least for me, and trying to learn this new avenue of science. I after I completed that course, I picked up the copy of Python Crash Course. I have a Discord link below for any new people or beginners, or any just programmers in general that want a community kind of makeup. I have a Discord where I provide a PDF of all the books I read, from the one you see on the screen above me, from data structures and algorithms in Python to Python Crash Course to uh, Fluent Python, which I have down here in my little stack of books. Python Machine Learning. I don't think I have that one published yet on there, but we are going to get into Fluent Python and Python Machine Learning soon enough. But we are currently reading DSA in Python. It's just a long, long book here. But we're also taking Harvard CS50X right now. So I'm currently taking that live on the channel, watching lectures, completing the problem sets live. So if you're wanting to do like a course alongside me, similar to like a CS50 type of CS50P for that matter type of feel, then consider doing that with me. It's a great opportunity to learn alongside me. I do have a little bit of experience with a CS50 format, so you could maybe benefit from just getting picked up right on in it and just not having to worry about the learning curve of the actual CS50 part, and then you can just focus on the actual programming with me. And yeah, so I do those quite a few times during the week, and on the weekends we watch the new lecture for that week. But like I said, I have these books in my description in my Discord below, along with a lot of other resources from my personal notes you see me taking that are pushed to my GitHub. Everything I have available to you guys. So thank you so much, and thank you so much for the birthday wishes. So if it's the 23rd for you guys right now of January, it's my birthday, and I really appreciate you guys being here with me and supporting me. You guys are awesome. Okay, let's get a drink of some lemonade here. Mason H, dude, if you're sorting, you're ready for databases. Um, I'm not sure. What do you mean? Like sorting in terms of, we just learned about sort stuff in CS50X in the week 3 on algorithms that we just watched. So we have to complete the week 3 problem set, and we learned about merge sort. We learned about mm, not good that I can't remember the other two. Not good. It's not a good sign, guys. Not a good sign. Okay, I want to read a couple more pages of the book here. I want to get to 335. Okay, binary search trees. An important application of the in-order traversal algorithm arises when we store an ordered sequence of elements in a binary tree, defining a structure we call a binary search tree. Let S be a set. So let me go here and let me make a little note here called binary search tree here inside the in-order traversal, which is so an important application when we store an ordered sequence of elements in a binary tree. Storing an ordered sequence of elements in a binary tree. Let S be a set whose unique elements have an order relation. For example, S would be a set of integers. A binary tree for S is a binary tree. A binary search tree for S is a binary tree T such that for a position P of T, for every position of P of T, right, The position stores an element of S, this of the sequence of integers, or the set of integers, denoted as element at position P. Elements stored in the left subtree of the position, if any, are less than E of P. Okay, so you just get smaller and smaller to the left and get larger and larger to the right, I'm assuming. Elements stored in the right subtree of P, if any, are greater than E of P. Okay. An example of a binary search tree is shown in figure 8.19. The above properties assure that in-order traversal of a binary search tree T visits the elements in non-decreasing order. The above properties assure that an in-order traversal of a binary search tree visits the elements in non-decreasing order. Non-decreasing order. Well, if you go left, you're decreasing. Bubble sort, that's right. Thank you, Wing Hong. Bubble sort, merge sort. What was the other one we talked about? It was like the brute force one. What was the other one we talked about? We'll have to get some practice with those when we do the problem set. Probably tomorrow or the day after or Friday. The weeks are just flying by here for me. So, a binary search tree storing integers. The solid path is traversed when searching successively for 36. The dash path is traversed when searching unsuccessfully for 70. Selection sort, that's right. 31 to 42 to 36 confuses me. Was it quick sort? I can't remember. 31 to 42 to 36. I don't think the order, think about it like this. I don't think the order so the order does matter, but I don't think like the actual deviation between these numbers really matters. It's just that they're generally lower than the root that they came from. So 58, if you traverse left from this root position of E of P, right, every node to the left will be lower than E of P, right? And say vice versa for the right side of E of P, where so at this root position, every node to the left is less and every node to the right is greater than 31. So that's why you have, it abides by the 58 node root up here. Everything down here is less than 58, but this 31 is also a root, right? It also is a root in itself on this subtree. So it also abides by these rules as well. So when you go to the right from this subtree, you have all positions that have the elements are greater than just per this rule up here, right? Does that make sense, Wing Hong? Hey, Easy Climb Tech, thanks for the kind words. I really appreciate you coming in and spending some time and leaving that message. You're awesome. How's it going with you? What's going on? I really appreciate you coming in. Uh, Introduce yourself. I really appreciate you. Thank you. What's the end goal of your learning? Just trying to get a job or a hobbyist? Well, yeah, exactly. The latter of that, I guess I never really thought of the word officially as a hobbyist, but I guess that is that. I currently have a job already as a chemist. I have a degree in human biology and a minor in chemistry. I work as a formulation chemist for a biotech company. Um, I'm currently like a mid-level chemist. I, enjoy it in terms of like the title, right? But so this is entirely just for gaining new education. I really value, teaching myself new things. It's just a part of what I enjoy and get a lot of value out of. I like being productive and continuing, stimulating my mind. And I just, I don't know. It's just something that I kind of need to keep doing. I don't know what it is about me, but I just like to keep going. So that's pretty much it. And then computer science is just a way that is just a way to express that. I just really enjoy the actual um, science behind computer science. I think it's really fascinating. Me being actually a physical scientist, I think that it's really, really interesting that we've been able to create these um, technological advancements out of these physical elements, that I manipulate in my ways to make, other physical elements, but these these the other scientists manipulate them to make, you know device. It just completely blows my mind, and I want to learn all about it. And so if you're interested in that as well, then consider following along here. We're just doing this for fun because I already have a job, and I'm not putting a lot of pressure on myself. This is for fun. This is at our own pace, and so we're really able to soak up a lot of information quite quickly because I'm not worried about a lot of the other outside factors about employment and things like that. I'm just sheer enjoyment out of doing this. Yeah, I graduated. Um, I have a Bachelor of Science in Human Biology and a minor in Chemistry. Yeah, Martin, that's exactly one of my reasons. Um, you know, I felt that people were often struggling to. I don't know. I can't say too much because I'm not experienced in that area, but I had this feeling that maybe people were under some false pretenses about what this was really like, and that's why there was a lot of bad representation out there. And um, you know, if you actually enjoy the information, then something will come along. I think like it's just in the ways of the universe. I don't know. There's not a lot of people out there that I think that really, really enjoy the actual, what we're enjoy these actual trees. Think they're fascinating to learn about traversing them, right? I think a lot of people just care about the status of being the engineer or whatnot, and it's I'm not really interested in that. I like the information. Lots of chats here. You guys are awesome. I wonder how to use that tree to print out the number in order. This guy's special if he's doing it for fun. What kind of special? Easy there, Rocks. I was looking for looking only for physics. Yeah, actually very cool. My buddy and I started Easy Climb Tech. Nice. We work at Meta and DoorDash, and they help people prep for tech interviews. That's why I asked. Very cool. Best of luck in your journey. Thanks so much for coming in, man. You're awesome. Thanks for supporting me. You're great. um, Mason, support chemicals with sorting. What? Help me understand why you sink into CS if the dangers aren't scary. MS currently. I'm not sure what you mean. Sorry, man. All right, we caught up here. Okay, let's keep going here. Thank you guys so much for the chats. You guys are awesome. If you're enjoying the time here, I appreciate if you guys follow along and throw a like on the stream. YouTube's been really recommending us to people and getting a lot of new programmers. I've been getting a lot of questions, a lot of interactions in the Discord and on YouTube with a lot of people that have supporting and enjoy it. So it's just great to keep getting it suggested to those people. So if you would be so kind and feel inclined to feel free. I appreciate it. Thank you guys. All right. We can use a binary search tree T for a set S to find whether a given search value V is in S by traversing a path down the tree T starting at the root. At each internal position P encountered, we compare our search value V with the element E at P stored at P, right? If the search element is less than E of the position P, then the search continues in the left subtree of P. If the search value is equal to the element at that position, then the search terminates successfully. If the value is greater than E at that position, then the search continues down the right of the subtree of P. Finally, if we reach an empty subtree, the search terminates unsuccessfully. In other words, a binary search tree can be viewed as a binary decision tree. Recall example 8.6, where the question asked at each internal node is whether the element at the node is less than, equal to, or larger than the element being searched for. We illustrate several examples of the search operation in figure 8.19. Note that the running time of searching in a binary search tree T is proportional to the height of T. Recall that that proposition 8.8 that the height of a binary tree with n nodes can be as small as log n plus 1 minus 1 or as large as n minus 1. Recall from Prop 8.8 that the height of a binary tree with n number of nodes can be as small as that or as large as n minus 1. Thus, binary search trees are most efficient when they have small height. Chapter 11 is devoted to devoted to the study of search trees. Interesting. Okay, implementing tree traversals in Python. When first defining the tree ADT in section 8.1.2, we stated that tree T should include support for the following methods. The tree.positions method will generate iterations of all positions of tree. Iter_t generate an iteration of all elements stored within the tree. Okay. At that time, we did not make any assumptions about the order in which these iterations report their results. In this section, we demonstrate how any of the tree traversal algorithms we have introduced could be used to produce these iterations. To begin, we note that it is easy to produce an iteration of all elements of a tree if we rely on a presumed iteration of all positions. Therefore, support for the iter_tree syntax can be formally provided by a concrete implementation of the special method dunderIter within the abstract base class of T of the tree. We rely on Python's generator syntax as the mechanism for producing iterations. Our implementation of the tree.iter is given in code fragment 8.16, where we define the iteration over the object itself would generate an iteration over the tree's elements. Right, because this is what it talked about over here. So we're defining like an order here for position in self.position. So this will generate an iteration over all the positions. Yield or provide back the elements at that iteration. Iterating all elements of it. Now, I'm not really. Does anybody have a good definition? We've been over it, but I don't have a good grasp on the yield with Python's generator syntax. They talk about it a little bit in this book at the beginning, but I just kind of, honestly, I didn't really pick it up that well. Anybody have a good definition in chat for yield when, specifically talk about Python's generator syntax? Iterating all elements of tree instance based on the iteration of the positions of the tree. This code could be included in the body of the tree class. To implement the positions method, we have a choice of tree traversal algorithms. Given that there are advantages to each of those traversal orders, we will provide independent implementations of each strategy that can be called directly by our user of our classes. We can then triply adapt one of those as a default order for the positions method of the tree ADT. We can then trivially adapt one of those. Okay. We begin by considering the pre-order traversal algorithm. We will support a public method for calling signature t.preorder for tree T, which generates a pre-order iteration of all positions within the tree. However, the recursive algorithm for generating a pre-order traversal as generally described in code fragment 8.12 must be parameterized by a specific position within the tree that serves as the root of a subtree to traverse. A standard solution for such a circumstance is to define a non-public utility method with the desired recursive parameterization, and then to have the public method preorder invoke the non-public method upon the root of the tree. Our implementation of such a design is given in code fragment 8.17. So what they're talking about here is that the method preorder doesn't actually, it requires a root to be given. Now, the user might not necessarily know the root at that subtree, or if it is even a root necessarily, right? So you could have a non-public method, encapsulated within this pre-order method, which is going to show us here down below. So here, pre-order self, generate a pre-order iteration of the positions in the tree. So if the tree is not empty, for every position in the self dot underscore subtree underscore pre-order, we're going to call self dot root on that. And so this function, what this does is it calls it on P, you yield that position, for C in self dot children of P, for other, what? So visit P before its subtrees. For each child, C, do pre-ordering of C's subtree, yielding each to our caller. Lots of chats here. One data structure I love to use. Hey Martin, appreciate you coming in. Ed Rocks, how you doing? Yield stops the function from continuing to exit. If you spread it over a list, it will dump its contents. So if you did a generator function to yield 3, 4, 5, you could spread the function and make an array 1, 2, 3. So does yield stop on that iteration and do something else? Like for every position in P, yield that position, but you yield, this is kind of confusing here. Hey, Bax, how's it going? Appreciate you coming in so much. Appreciate you. You're awesome. Unless you call it's next or continue iterating over the generator. Hmm. So it like so let's say you have a list of integers, right? It'll iterate over the list of integers. Let's say I have integers 1, 2, 3, 4, 5. If I yield the integer for number in numbers, yield number, will it hand back the zero index number to the user and then wait for the user to do something with that number before continuing the iteration? Or how does the user then, trigger the iteration to continue then? Or what is even the whole point of doing like a yield? Like what kind of application does it like serve? Subtree preorder yields. Lost me at yield. I've never used it. That's what I'm saying, right? That's what I'm trying to figure out right now. I've never had to use it. Like why? Like what kind of application within the memory it processes the generator call? Hmm. Interesting. So then what is going on right here? You call self.root for position for p in this function on a root. You're given a root, you yield that root for child in children of p and for some other variable in. So you initially yield the position of the root and then you yield every position of its children. Rocco, that's a good idea. Here, it is not intuitive for what it could be useful for. I've used it a lot. It's primarily for non-linear searching. So say I want to iterate over a list but ignore certain elements. Oh, so you can like yield over a certain element? Like if element equals this, yield element, and then it'll skip that element? Hmm. Let's do what Rocco suggests here. Break down yield ooh, in Python for a in simple terms. Super simple terms. All right, here's yield. And yield is like a pause button for a function. Instead of returning a value and stopping, it gives a value but remembers where it left off. When you call the function again, it picks up from where it paused. Think of it like a vending machine. You press the button, it gives you a snack, yield. The machine doesn't shut down, it's ready to give you another snack next time you press. It's often used within loops to create generators, which are like lazy lists. They give you items one by one as you need them instead of all at once. Oh, wow. Mind blown. Interesting. So you can provide items one at a time back to the user. So let's say you had like in like a practical example, like a list of like, well, like think about this is like a dating app. Is that does that yield you users to swipe on? Like a list of users in its database, and does it pluck one out from its memory that that matches your algorithm and then yields that member to you? Is that a way to look at it? That's kind of like, or like a queue almost, right? Or like, I mean, a queue would have that has order, right? So I'm not sure. It's like return, but instead of returning a function, it pauses the function, saves its state so it can resume. ChatGPT said. Yeah. The yielded element is returned. That's a good example. Wait, that's a good example. Are you guys talking about the vending machine example, or are we talking about the dating app example? Which one are we talking about? um, Now the vending machine owes me money and a drink and tracks drink inventory. It's really similar to a queue. You don't really use it like a normal function, you iterate over it, the vending machine. What happens when a snack gets stuck and you have to shake the vending machine? um, what is that, like Stack Overflow? I don't know. Probably not. Ah, the vending machine example. Dang it, it's not my dating app example. You guys don't ain't showing me love. Use the delete key. You just control C the vending machine. Just control C, right? Okay. At least on Mac, yeah, I can or yeah, your loop control C. Okay, we're almost at 3:35 here. Um, Formerly, both pre-order and the utility subtree pre-order are generators. Rather than perform a visit action from within this code, we yield each position to the caller and let the caller decide what action to perform at that position. The subtree pre-order method is the recursive one. However, because we were relying on generators rather than traditional functions, the recursion has a slightly different form. In order to yield all positions within the subtree of a children's child C, we loop over the positions yielded by the recursive call self.subtree preorder C and yield and re-yield each position in the outer context. Note that if P is a leaf, the for loop over self.children P is trivial. This is the base case for our recursion. We rely on a similar technique in the public pre-order method to re-yield all positions that are generated by the recursive process, starting at the root of the tree. If the tree is empty, nothing is yielded. At this point, we have provided full support for the pre-order generator. A user of the class can therefore write code such as for P in t.preorder, visit position P. The official tree ADT requires that all trees support a positions method as well, to use a pre-order traversal as the default order of an iteration. we include the definition shown in code fragment 8.18 within our tree class. Rather than loop over the results returned by the pre-order call, we return the entire iteration as an object. So def position self will return the pre-order. Interesting. This is getting pretty, this is getting complex here fast. Um, he's learning. So I'm going to give it this. I'll say, break down this, please. Pre-order traversal. In pre-order traversal, you visit a node first, the root, then recursively visit its children. The code uses yield to produce positions at one time during traversal. Pre-order self. In this main method to perform, this is the main method to perform pre-order traversal of the entire tree. Line 81, if the tree is empty, it starts the traversal of the root. Yep. Line 82, calls subtree preorder self.root to recursively traverse the tree starting from the root. Line 83, it uses yield to produce each position at the traversal progress. Okay. So just this function here just does some traversing, so it yields the position initially. So this is a helper method to traverse a subtree starting at a specific node P. Line 87 first yields P, the current node. This is the visit step of preorder traversal. It loops through all the children of that position, P. For each child, it recursively calls subtree preorder C to traverse that child subtree. During this recursive travel, it yields each node back to the caller, which could either be the parent or the main preorder method. How this works step by step. Let's say we have a tree that looks like this. Calling preorder. The tree isn't empty, so it starts at the root A. You call subtree preorder A, which yields A. For each child of A, B, C, and D, calls subtree preorder on B yields B. For each child of B, E, and F, we call subtree preorder E recursively, yields E, yields F. And then we call that for C, which yields C and D. So, okay, so like the preorder, okay, I got you. Instead of creating a full list of nodes at once, this approach produces nodes one by one as needed. It's memory efficient for large trees since it doesn't store all nodes at once. Ah, interesting. This was really helpful. Okay, cool. Nice. All right, let's keep on. All right, so that's going to be it for data structures and algorithms in Python. Let's move on to something else here. Are we using this function elsewhere to search for an element? I think they're just showing you like a representation within Python itself for, creating these classes to have these data structures, right? It's now, yeah, that's like kind of all I can really say on it, I guess. We're on 35, 335 now. Okay. let's go ahead and pull up our small business manager project. So for those that are new here, we do live projects, right? I write my live projects as well. We learn about code and learn about computer science topics and everything, but we also need to apply them into our own projects to solidify those learnings. So right now we're writing the small business manager project. I'm not going to do too much work on this today just because it's been a long day for me. I've been obviously at work. I was at work, from all day today, and then I had that chemical mishap. If you For those that weren't here at the beginning of the stream, I was late to starting my stream by quite a while. I usually start my stream around 7 p.m. PST, but I started it around like 8:30 today because I had a mishap at work. I was just at the wrong place at the wrong time, and someone was filtering their chemical solutions, and they something happened with their setup, and I don't know what happened, but I was just right there walking by, and it blew, and it went all over me, and I had to go to like the urgent care and get cleared out and stuff, and so it was just a fiasco. But no harm, no foul. It's all good. It's part of the lab, but just it was a long day for me today. So okay, so this is the small business manager that we've been writing, and yesterday we worked on this business class, right? So we have an item class which generates items. We have an expense class which generates expenses, and so now we have a business class which will house relevant information um, to that are gathered from our main script here. So yesterday we wrote this initialize revenue function where we initialize some empty dictionary. We iterate over all the rows basically in the passed in all items dictionary. So the all items dictionary is passed in via our data structure here, which is just a dictionary data structure, not too elaborate, but or like a hash map, honestly. So it uh, we access our items in constant time via their item numbers and stuff. So that's why I kind of set it up that way. Why are you learning this? Yeah, just as Martin said, free will, I guess, right? I just like doing, things that challenge me. I like learning. I liked school growing up. I enjoyed my time there, at least for the most part. I wish I was back, learning this officially back in school. So I work as a chemist. I have a 9 to 5 job, but I I don't I get gratification out of it and satisfaction, but it's working for somebody else at the end of the day, and so by doing something like this as well, I'm able to kind of I don't know, make things into my own. I don't know if that's a way to put it, but when you get caught up kind of in that corporate uh, just routine, I guess it can get kind of you're like, man, I remember back in school, I was constantly just doing things for myself and excelling forward in my education and stuff. And now I'm just constantly doing something for somebody else. And so this is also just a way, A, to, have a hobby, B, to gain additional skills and continue my education and learning and becoming smarter and a better overall, person and uh, whatever. And then, C is that I get a lot of like that personal gratification that I'm accomplishing something with the channel as well. Yes, I am employed. I have a job as a chemist. I work as a chemist. Put the bacon in the bag. Does this have a place to plug into? What? Not sure what you mean, Mason. All right. Um, I don't really do like I haven't done any like I don't any like CS interviews. I work as a chemist, so I know interviews and stuff for chemistry, but we just started doing some leak code practice, a neat code practice. We've only done like 3 or 4 of the beginner problems, so um, yeah. Put the bacon in the bag. Does this have your program? What? Where's my program have bacon in it? What are you talking about? So, yeah, so we create this, we iterate over all of them. If the item has a date sold, we access this dictionary here. We make a slice for the date sold, right? So we find the date sold here. We take the first four, and we apply it to uh, to that, and then we increase if it's there. Else, if we get a key error, meaning that that key is not there, we create the key and assign a price to it, right? So this is the way that we've been able to dynamically kind of create a revenue, for every year that is currently in our database. Now, to show you what's going on here, I have, four items here in our database. We have an item that was sold in 2025, 2025, 2024, and 2023. This is 5,000 US cents, 5,000 US cents, 5,000 US cents, and 10,000 US cents. So if I run my main program here, would you like to open the Small Business Manager by Michael Deming? Yes, I would. All right, we'll go to the or hold on. I removed a print statement from this that did something here. So I need to go, sorry. Print, what did we create the business as? We created as business details. Dot revenue. So we'll print this here and you'll see what happens. So it'll print at this menu, but right above it. So I go in yes here and I'll pull up my my items list, as you can see here. Boom. Which is really cool, is that now we get this iteration over all of our items. We, successfully group together, items that are 2025 with that slicing, and then we, group together their amounts, right? So 2024 and 2023. So now we're successfully able to display revenue, total revenue, across all of our sold items in our database for every year that we have current data for. So it's really, really cool. Um, Joshua, I know I really appreciate you asking. What does that kind of entail? I don't really know what that would, depict. Do you have any like examples or something? Or, I really appreciate you following me here. Yeah, thank you so much for that support. I, yeah, to be honest, I would be interested in it, but I just don't know much about the kind of interview style, and I think I would look kind of like kind of foolish. But I'm definitely willing to learn. But like I said, I only am kind of just starting into that neat code, leet code grind of because I just kind of am now starting to get comfortable with the beginning concepts of DSA and time complexity and stuff. I still got a long, long ways to go, but what do you think about that? What other type of videos do you make, Joshua? Um, Thanks so much, Rocco. I appreciate you coming in. What's your story? I appreciate it. I share it with you. You got to share it with me now. I love hearing about you guys. Mason, what's the numbers? What do they mean? Are you talking about Black Ops 1? Yo, Yub, how's it going? What's going on? I'm gonna watch this and get better at Python. That's the plan, right? I appreciate you joining me. We're getting better at Python together here. I only made front end stuff. Like on your channel, Joshua? But I'm at Microsoft now prepping hard with LeetCode. Oh, nice. That's really awesome. How do you enjoy that? Martin Watson, yeah, I'm a Master CS grad. Nice, dude. That's really sweet. I contemplating whether or not to go back for um, a bachelor's, a post back in computer science. I would only have to take 2 years more of classes because I already have all the undergrads out of the way with my current degree at my alma mater. But it's definitely a thought I've been thinking about. Machine learning, yeah, I definitely want to get into that. I have a Python machine learning book right here that we're going to get into soon. So definitely will need your help with that, Martin. All right, so that I just have that print function to display that to you. So we have the ability now, right, when we initialize in our main program here, once we create the all items and we create the all expenses on loading our files and on startup, we generate the business, right, with a name, and we'll have this. Well, this is just a test, right? But we'll also have some file, probably a JSON file for the business itself, and inside there it'll have a name, and we'll just pull that and declare it from there. We'll load the file and declare the business from there with that pertinent information or necessary information. Um, and so, but we will need to save this information within that file. So when you initialize the business on every startup here, you'll get the updated revenue for that day. But then we'll also need to create a def update revenue function, which will take in self and take in some amount, right? We'll say if amount less than if amount less than 0, return or raise value error for print, or say amount, we'll say f string amount can must be a positive integer, right? But then we'll say so this needs to be int here, and this will what, return none. It doesn't return anything. So do you, for type hints, you guys, does it say, do you if you aren't returning anything but you're just updating a value that's already existing, do you say this right here, just arrow none? Because I'm not returning none though, I'm just returning nothing. I'm also learning something by myself, machine learning. I've been thinking of doing something like that, but you do it in Spanish. I imagine this kind of stuff keeps you accountable, and so also sometimes also feels kind of being alone feels kind of sad. Yeah, exactly. That's, you're right on the nose there. I feel like this stream, uh, just I do feel like people enjoy learning, but I also feel like the aspect of kind of being alone and having to go through that process, um, you know, uh, to be a little bit, discouraging. Be I don't know. I really think that people just value companionship, and I can provide that here through the stream as well. Well, you don't have to be deliberately working on or watching whatever I'm doing on the screen. That's just a byproduct. If you happen to be someone that's interested in what I'm doing, and entertained or whatever by what is going on the screen, then that's just a cherry on the top, right? But you can also, we have a few people in here that also just use the stream as a way, because I do daily streams to hold themselves accountable in their own work, whether it be their homework or their classes or their work for actual profession or whatnot. their small business. They we have accountability between you and I or whatever, where I'll come on stream, and if I'm working on whatever I'm working on, then you can be working on whatever you're working on, and we can just be here together, occasionally chat in the chat if you have something you want to say or something strikes your mind and you want to talk to me or something, and we can have a conversation that way. It's no different, in my opinion. My whole goal was that, like, as if you and I, you being the chat or whoever is out there, we're just like booked a study room in the library back at university, right? We just booked one online, and we were just met together. So that's kind of the feel I wanted to bring to it. This is not like a teacher student dynamic where I'm like trying to convey these topics to you. No, no, no. Like, I'm trying to learn these topics for myself, as like a beginner. And if you happen to also learn something from that, then that's just a byproduct of the stream and what it's supposed to be doing. Because at the end of the day, I'm a beginner in this, so and you should be doing your own research and work into things, and coming up with your own ideas and things like that for the most part. But obviously, we can have that collaboration in between to help boost each other up. So we got some chat. I say stay with your regular job. CS at university is trash. You learn too much, but not enough. Daily practice and studying Python is enough. I miss the feelings that used to stay when I was naive. Yeah, Martin. I'm sorry we're getting into some of these tangents, but that's one of my another one of my theories. I talk about on my stream a lot. Is I really feel that computer science is unlike any other industry, maybe besides healthcare. And I say that because, um, or maybe like maybe like biology, healthcare, like and stuff, because a lot of those are now intertwined. Right, technology is now intertwined a lot into healthcare. Um, because of the fact that new scientific research or advancement is coming out in this field, it seems like every 2 months, every 3 months, there's something big coming out. With AI, it's even big. Like, it's just there's something new coming out in terms of biology and chemistry. You might have a new finding come out every so often, and then that's a new class that you have to take at school, right? But with computer science, it seems like a new class or whatever gets added on to the curriculum like every 6 months. And so at this point, students are being spread so thin. Maybe this is all theory, right? So if you guys have experience, please chime in. Are students being my assumption is that maybe students are being spread so thin, and like not their fault at all. It's just the circumstance they're in, that they are forced to have to not practice projects and code. They're trying to just survive the classes, and then also find internships outside of those classes, make connections and network, and then just the sheer amount of homework though that is required from some of these classes. Like when I took like my physical science classes, like my biology, like my some of my advanced bio, um, you know like physiology and bio classes, and some of my like physics classes, like I had to put in like hours and hours of work and practice into learning those concepts, memorizing those those microscopic you know uh, bodies or whatever. And or in like physics, I remember going to the learning center and working with the grad students to go over practice problems, because it's just, I don't know. What do you guys think in terms of the expectation to learn the mass amount of material that seems to just be endlessly growing? Um, I only do type hints if the function is supposed to return an explicit value. I generally don't use type hints on none return none return as it's the default, I believe, but it might not be the best practice. I get Martin radiology. I took a shot at making a goal. Type hints are good depending on programming language. SQ, I love it. Okay. So we won't return. No, we'll just say this then. So we will try to int amount right? Except value error um, amount equals quote amount um, cannot convert to um, I don't really like having this error message twice. Is there any way I could combine this? So we'll try to convert the amount except for a value error. Is it a value error? I don't think it's a value error. It might be a type error. Is it a type error? Um, what, oh, what error is raised with with stir to int convert value? Okay. Ooh, value error. Martin says, yeah, there's like 10 different branches we can learn at my school: AI, embedded systems, and the medical sciences, systems programming, front end, back end, web dev, low level systems, databases. Yeah, it's just like, right, it's just like what, I don't know. It just seems like such like a, I don't know. I feel weird about like I want to learn it all, but it feels strange to have to like choose um choose a path, right? I feel like it's a, especially for the amount of money that's being required, it just feels like it's what am I trying to say? Like it just, it's like such a difficult decision because you're paying such a large sum to then kind of bottleneck yourself down a certain avenue. I mean, it's probably like it's like that, I guess, for any kind of major really. Or really, you could just print message, right? So we get a message. We have a message set up. We try to convert the message to the amount provided to an integer. Except if we get a value error, we just print a message. If the amount is less than 0, we raise it. Uh, Raise the error. So in our program, we can catch this error, right, when it actually gets risen, if we come to that. So then, else, right, if that doesn't get risen, then we'll say we'll access the self dot revenue. So this actually isn't going to be an amount. This is going to be an item. Right. And I'm going to get an amount from the item. I know I can just insert this directly, but I already have amount written out. So I'll say amount is equal to item dot um, sold price. So we'll get the amount here from sold price from the item, right? We also need to account for the date in so we have revenue, we access self.revenue. And then we'll say year is equal to item dot date sold slice through 4. Yeah. And so that's going to be a string. Oh, where am I? Here. So that's going to be a string. It should already be a string, I think. But because I'm not stringing, yeah, so it's already a string. Self.revenue will access the key for the year plus equals amount. Just like that. So what we're doing is we're accessing the year of the item provided, given that it's an item from this class, right? We're accessing the amount from that item, because, right, so the date, you might think, well, why am I doing this syntax? Well, the date is given in this format here, and I only want the first 4 characters of that date string. So we take a slice off of it for the year. The amount is equal to the sold price of the item. And we have a message here for the error message, right? We try to convert the amount provided to an integer. It should already be an integer though, so we don't need to do this. It's none, but then we have, when we load files, we call int on sold price if there is a value there, else none. So we don't need the int conversion. So I'm going to give a type or a thing. Update the self dot of a business class instance given requires an item of the item class a parameter. So we want to try and get this though. If amount is equal to none, we want to raise the value error. So we'll say it there. Right, because technically the amount can be none. Because let's say that we accidentally call an update revenue function on an item that hasn't been transacted as sold yet. So maybe I should say like this. If item dot date sold, do this, assign year to that, else raise attribute error for item is not sold. It's not, is not sold. So we will raise an attribute error if we can't actually access these. But let's say that they have a date sold, but maybe not an amount, like it's something a fluke, then we'll throw that there as well. Oh yeah, right here, Lo. You're all good. Sometimes I wish I can pause time and learn everything I can in CS, then resume. Yeah, right. I feel that way too. Definitely. Time just keeps on chugging away. Even though this is not really a race against any time, it definitely feels like, man, 6 months has already been going by. Wow. If you want to test its class, you could use type instead. Directly using string or int forces a primitive to swap values. So if you mistakenly pass string quote 2024, you'll wind up with 2K ITM. You could use type instead, directly using string. Oh, I got you. So you're wanting to use type just to check. But I think in this specific circumstance, when I was using that int conversion, I was wanting to convert to an int, so I could do math operations. But the item sold is already being converted to an int. But yeah, thank you so much. Yeah, that's a good idea. Or like is instance for a certain, or is instance I guess would be for more of a data type. Like is instance Well, is instance would work for like the int, right? Uh, should you use is instance or type? Depends on the situation, but most cases is instance is preferred over type, and here's why. Use is instance when you want to check subclasses. An is instance checks if an object is an instance of a class or its subclass. This is helpful in an object-oriented program where inheritance is involved. When to use type? When you want an exact type match. Type only returns true if the object is exactly the specified type, not a subclass. Okay. Um, are you handling the case on? Yeah. I say that because AI keeps improving and I don't want to learn all this for nothing. Yeah, right. I got you. I would honestly, my mentality with it is I know I'm in a different circumstance, right? Being I already have I'm in an outside profession trying to like, whittle my way in and see what's going on here and just take a peek. But and I appreciate you guys for being so willing and accepting of me. You guys are great, right? But um, I don't really like fear AI or anything all that much. I know a lot of people come into the comments here and will kind of troll a little bit and be like, "Oh man, what are you doing? You're wasting your time." And I don't really know. I have this feeling that yeah, it's going to be really really helpful, but I mean, look at like trends, like look at human trends like as a whole. Like try to not like narrow the vision or the window you're viewing like all of human history or things like that. Like now I know that we've never had anything like this happen before and it's completely unique, but you know people still utilize like retro equipment today in various manners. They also value vintage or old things. I also think people in general are just slow for change. So the only real people in my mind that are going to be using the AI at the present moment are going to be young people and people with lots of money. But the people in between, they're going to be stuck in their old ways. And so I really do think it's going to be like a 10 to 15 to 20-year transition because you can't force these people that have no desire to learn those technologies. Now, will it come to a point where they just get replaced? You know, I don't think so. I do think that there is great value to the actual human connection. And we kind of always do these circling backs where we make very drastic announcements, right? Where we make or advancements or we make drastic advancements, but then we kind of circle back to realize that we actually did enjoy the process before a little bit. So let's kind of, you know, have it best of both worlds. Like it happens like with anything, with video games and with movies and with pop culture, like these tropes and these whatever. I know we're talking about technology here, but you see it in media and things as well. Um, I don't know. I just have this philosophy mindset where I like to think about these kinds of things and I also just like to not stress out about that stuff. If you start thinking about you're going to be replaced by technology, I mean, if it does come true, it does come true. You'll adapt as a human and you'll grow from there. Like that's just what humans do. But I mean, really, like why stress out about it if it is inevitable to happen or isn't inevitable? Like just if it will be, it will be. If it won't be, it won't. So why are you specifically really that worried about it? Like, I mean, it's not like I'm the one that's making it right now or like you guys are either. Like if you are, like that's really great. Some of you guys are doing machine learning, right? So, but I don't. I think it's just a lot of. I think the media really plays things up, but we don't have to get into all that crazy. um, sorry for that yap. They're basically the same thing. It doesn't really matter for prims though. Oh, gotcha. Hey, Solakin, what's going on? Working on a game together. That's sweet. You guys are sweet. You guys like in a call together? That's awesome. Deciphering an AI complexity. I'm currently in my last two semesters of master's computer science. Good AI is what they sell. Good AI is still worse than the beginning level programmers. It will likely replace millennial work like help desk, but nothing like crazy like a real developer. If a company could replace a developer with AI, they would. However, that would be the scariest thing to do. Human labor is simply cheaper than AI labor. Yeah, honestly, that is true as well. Like, you have to also think about the costs of AI labor versus human labor. And currently, unfortunately, human labor is still being exploited, very, very prevalent. If you're kind of young and you're not in the workforce and aren't like really reading these news topics and seeing like the current, like if you're not actively like either looking for jobs or in the market like at like a big company, you'll see like um, that people are still being exploited by those professions and in terms of what they're able to produce, and people just are okay with it because they really don't have any other options, unfortunately for them, um, and it's just really, I don't know, what it's just unfortunate circumstances all around. I really it's hard, rocking a hard place. I don't know. But yeah, you have to think about it like the amount of resources in terms of like water, electricity, and energy that the AI currently takes up to manage, as well as all of the salaries that are used to produce the AI from the developers. It's just not feasible right now to make that replacement. I think, like I said, it's going to be a 10, 15, 20 year transition. And even then, is you'll have a generational gap where people that are above the ages of 30 will not care, right? They don't care. They're busy, having kids and making having families and trying to like, survive at currently. I really don't think that they care about that stuff. Like the 35, 45, 55-year-old generation, unless they're like working in those areas, do they really care? Like, um, I mean, think about it like Salaka, and think about it like in terms of 10, 15 years ago when you were trying to build a PC, like, and when Nvidia stock was at like $2 a share or whatever, you try to buy an SSD, and for 128 gigabyte SSD you're paying $400 for a 128. Now you're paying like $50, right? It's just like that's a what, 800% increase. So no. Oh my gosh, I'm trolling. Um, 200. Oh my gosh. 400. Yeah, 800%. 100 to 400 would be 400%. 50 to 8 for 400 would be 800%. Because 50 to 100 would be 100. Yeah. I'm tripping. It's been a long day. um, yeah, that would burn up your waterways. I hope you enjoy. Yeah, Mason, that's a great way to look at it. Murad, hey, I'm watching that 22-hour JavaScript tutorial by super simple devs who are learning together, man. Awesome. That's great. Let's hold ourselves accountable. Let me know how that goes. I'm very interested in knowing how that course is. Let me know your experience and what you think about it, Murad. That's awesome. How's it going with that so far? Martin's really getting economical over here. He's breaking it down. Yeah, I really don't think, Mason, like you said, I think people don't realize that we're in this kind of this period of I mean, we've kind of always been in this period because humans have been, but we're even more so, in my opinion, of great transition. Um, it's going to be a long, tough road, but I mean, it's kind of like on that evolutionary process. Like you go through these waves where, I mean, with like you can think of like COVID and things where you have like, it's just evolutionary. It's kind of like that survival of the fittest kind of thing where it's just natural selection like really picks off things, and it's just the ways things. I don't know. It's hard to explain, and I just getting yapping over here, but. All right, you guys. I really appreciate you guys joining me today. It's currently 11 o'clock for me. We streamed for 2 hours and 5 minutes so far. We did some light reading into data structures and algorithms in Python today, and then we just did a little bit of work on, including this update revenue method for our small business manager business class here. So now we successfully, initialize the revenue upon instantiation of the business class, but now we can actually arbitrarily call update revenue to update said amount for when we live, transact these items into our database. So we'll need to include this method upon transactions. So like in the um, in the transact item menu, if we transact an item, right? Um, So if we transact item for sale or item is sold, right, which means it's been paid for, right, which is case two here, we will get a item date a date item sold, and then we'll get a sold price here as well, and so we can take those two values after we update the method of the item itself. So we provide the item here. So right here, when we update those methods, we can then right here insert um, insert here the update to business revenue, right? So right here is we're going to update business revenue with said item sold price and item date sold information. So really, it would just look like this. Business details dot revenue dot update. Update revenue for the item, right? That's all it needs. So if item date sold, we'll go ahead and get the year from it. Else we'll raise an attribute error saying that the date sold, the item is not sold and doesn't have this attribute yet. Right, because the item provided isn't, it is the right item, but it doesn't have this specific item here. Or date sold, rather. It's not sold yet. We'll get the amount from the item via the sold price, and we'll update the revenue here if it's positive and it's not none. Hey, Shanak, welcome. Awesome. I appreciate you coming in. Unfortunately, I apologize, but I think I'm about to actually wrap things up. I'm kind of wrapping things up, but I really, really appreciate you coming in this evening. And I know that we kind of keep missing each other on the back ends of the streams. So I'm going to try my best to stream earlier in the day on the weekends so I can try to get some of our international and East Coast friends to join in. But thank you so much for being here for the tail end. I appreciate you. It's an amazing and in-depth tutorial. Love JavaScript. Have a good night. Thanks, Murad. That's awesome notes. I'll appreciate that. I'll have to ask your question some help for JavaScript when we get there in CS50X. We're going to get to JavaScript soon. We have to understand each other. CS is a language. Nice stream, Michael. Thanks for the vibes, bro. More success to chat. See you all around. Good vibes. All right, see you, Mason. I appreciate you coming in this evening. I'll see you tomorrow. Later, man. Thanks for following along and helping out tonight. Appreciate you so much. You're awesome. Thank you guys, all you guys that are here. If you guys are new here, thanks so much for following along with me. I've been teaching myself Python for about 6 months now, 6, 7 months. I've been really going hard and heavy for the past about three, where I've been doing the daily streams for 2 months. And um, oh, you're in San Diego. Awesome. Cool. Well, that's even better. I think I'm confusing you with someone that reached out to me that said that they get. Sorry, my fault. San Diego. I'm man. I would love to move there. I love that place. San Diego's a cool place. You been to Legoland? um, but yeah, I've been teaching myself Python for about 6, 7 months. I started with Harvard CS50P. It was a great introduction to programming, but I filled the gaps in with Python Crash Course, this book behind me. I have a copy of this book and other resources on my Discord linked in the description, completely free. It's a kind of a setup as a roadmap of all of my learning, so you can follow it as well. I also have, all members have also provided their resources. Um, and so I've been teaching myself Python right now. We've been writing a live project from scratch, multiple files, imports, exports, file I/O. Really an intuitive, kind of cool program got going on here for managing small business and all of its details that it possesses. And then we also do like live learning of data structures and algorithms in Python. So we're on page 335. We read this like I read Python Crash Course live on stream a few months back when I was learning. We're now moving on to harder things in DSA. So this just shows you that this learning is compounding, and it's really, really cool and it's really nice to see that it's working, and that I can see directly that we're able to, you know, like like 6 months ago I could not write a single function, and now 6 months later I'm pretty much able to read these functions I'm writing as if I'm like reading almost English. Like it's like I 6 months ago I couldn't even write functions. I've never seen hello world before, and I struggled through Harvard CS50P, but now I'm able to kind of just formulate ideas and just write, right? Which is really cool. I'm able to just kind of convey my thoughts and write out kind of English. Now, yes, I'm a little bit slower, and I'll get faster and faster and faster, but from where I was 6 months ago, I mean, it just goes to prove that this process and this kind of roadmap that I've been doing with Harvard CS50P, Python Crash Course, project, multiple hours and hours of project practice, Harvard CS50X, data structures and algorithms in Python. All these things combined have really set us up for success for the future. So if this is something that you're interested in, seeing and continuing in your own right and just kind of following along with my progress here. I've been documenting everything on my channel here, and being completely transparent from like a beginner's perspective, because when I was initially trying to find resources, I felt that there was kind of a disconnect with kind of those YouTube gurus out there. They all were very advanced and honestly didn't really convey what it was truly like to struggle as a beginner, because they were just kind of out of touch with it. And so I wanted to try to bring that to the table and convey an authentic kind of POV of what it's like to sit here and scratch your head at some of these problems, because that's just the reality of it. I found that there was way too many people out there that was saying that they mastered this in less than a year and they got a job paying $1 million out of it's just not true. And I think that those people are liars, or are just or outliers. And so and I think they just discourage everybody else from the reality of what it truly is, and the struggle, honestly, that it is, especially trying to do this independently. So I appreciate you guys joining me today. I'm sorry that this one was a little bit shorter at 2 hours and 13 minutes. Like I said earlier, I started the stream late. I usually start around 7 p.m. PST and go till about now, or 10:30 ish. So about a little bit longer than this one tonight. But I just had a mishap at work where I was exposed. I'm a chemist. For those that don't know, I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company. I graduated back in 2021, and I've been working ever since I graduated. Um, I I got exposed to a chemical today at work. Just sheer luck. I was just walking by someone that was doing their filtration, and I don't know if they didn't have it set up properly or whatnot, but or what happened, but it popped and it exploded, and the pressure blew on it, and I was just at the wrong place, and I caught the blast basically, and it went all over the side of my body and on my hair, so I was like, I had to like wash it out, and a coworker of mine got completely soaked, and he was in the emergency shower rinsing off. So luckily, it wasn't corrosive or flammable or anything dangerous. It was just a stinky biological um, kind of conjugate. But so that's my excuse. So, anyways, I appreciate you guys being patient with me this evening and waiting for me to come on tonight. But I do jump on stream around 7 p.m. every day. And then on the weekends, I do a little bit earlier to help out with the East Coast and International. But I'm going to wrap it up for today. Like I do say, I do work 9 to 5. And my birthday is in less than an hour. So if it is January 23rd for you right now, if you're in the future, for me, I'm on Pacific Standard Time, but January 23rd is my birthday. So I'm gonna hop off stream, watch some shows here, and have some dessert, and just hang out with my dog, and bring in my birthday. I'm turning 26 years old, so I'm gonna do some reflecting and make some goals for this year. I want to continue with programming. I really want to finish data structures and algorithms in Python this year. I really want to, finish this project, grow the channel. Obviously, it's been really awesome. Grow the community really. Um, it's awesome that you guys are supporting me here. I'll show you guys, just if you guys want, join the Discord here. We have a lot of great resources people are providing. I announce my streams live here and any other videos. I got a Python crash course, my personal notes, a copy of the PDF, DSA in Python, Fluent Python, the book, EPUB version. I've got Odin project notes that I've done from when I've got about half that course done. We've got CS50X. I've been making weekly updates to my threads for when I complete weeks. So we're on week 3 right now. So when I complete week 3, I'll make a new one. I'm going to be doing the same thing for CS50P that I've already completed. So I just need to go back to my repo that I have for CS50 and transition that over. And then eventually my goal is to also continue on with our learning journey. I've learned up through Calculus 1, but I will say I need a refresher definitely on Calculus 1. And I want to get into some deeper level math on the channel and continue that. I just find it all interesting. So if you're interested in learning alongside me and just kind of hanging out with me and just generally improving yourself in your education, whether it be directly with what I'm doing here or whatever on your own, and just holding each other accountable, then follow along and join the community. And I really, really appreciate you guys supporting me, and you guys are awesome. And honestly, I say that every day, and I beat the dead horse, but it truly is the truth that you guys make this so fun, and make this more enjoyable than it already is enjoyable for me. So awesome, Martin. I appreciate you. Thanks so much for the birthday wish. You're awesome. I appreciate you coming in this evening. I'll see you guys tomorrow, all right? I'll see you 7 p.m. PST. I'll make a announcement in the Discord and for when I'm coming live, and I'll talk to you guys tomorrow. See you guys. Thank you so much.